There's an aircraft being designed in California right now that challenges Airbus and Boeing to their core. And it should. United Airlines has committed to a pathway to purchase up to 200 of these new jets, comprising of 100 firm orders and 100 options. This isn't far away either. We could see this aircraft flying a demonstrator within 24 months. The company is investing $4.7 billion in a brand new North Carolina factory that could eventually employ over 14,000 people. The company behind this is called JetZero, and it's taking the outdated tube and wing concept that we all know well and flipping it on its head with a full-scale blended wing body airliner known as a BWB, and they're calling this plane the Z4. This is a plane that will carry up to 250 passengers and change the way we think about commercial aviation forever, and the physics actually work. So why hasn't anyone built a plane like this until now? Well, to understand, we first need to take a step back for a little bit and talk about what we have right now. Boeing 737 MAX delivers a 15% better fuel efficiency than previous generations of 737s. The Airbus A320neo, you can expect about a 20% fuel saving as well, with its new engines versus the previous A320. Airlines celebrate these gains. They've ordered thousands of these aircraft. It's progress that keeps the Boeing and Airbus duopoly generating steady revenue. But competition is coming. The thing is, JetZero's blended wing body promises less aerodynamic drag, and the company claims that due to the BWB's design, per passenger mile fuel burn could be lowered by 50%. Here's why that's significant. You see, for the past 70 years, nearly all major gains in fuel efficiency have come from advances mostly in propulsion, and materials as well to some extent. We're talking better engines, higher bypass ratios, and more efficient combustion. JetZero, on the other hand, is attacking the other half of the equation, the airframe itself. Before we go deeper into that, just a quick one. If you're new here, I'm Aaron, and I've been in the aviation space for almost a decade. Back in 2018, I founded Simple Flying, which became one of the world's largest aviation news platforms. I'm sure many of you have heard of it. I ran it with an incredible team for over 3 years, and then it was acquired in 2021. Aviation has been a lifelong passion of mine. I even wanted to be a pilot once until I realized I was terrified of flying. Thankfully, that didn't last too long, and I figured with so many AI generator channels popping up on YouTube in the aviation space, I wanted to do something a bit different, to show my face and to share my genuine experience and expertise about commercial aviation from someone who's actually been in the industry. So if that does sound like your thing, subscribing will really help this channel grow, and it would really mean a lot to me. And now, let's get back to JetZero, because what they're building could completely redefine the shape of commercial flight. The blended wing body design eliminates structural penalties of bolting wings onto a cylindrical fuselage. The entire aircraft will generate lift. The fuselage will literally become the wing. The surface area drops, interference drag disappears, structural efficiency will skyrocket. Really, Boeing and Airbus have been refining the same basic plane concept for 7 decades. Better engines, longer wings, winglets, sharklets, and composite materials. And aviation design firms are openly acknowledging that opportunities to create step changes within the tube and wing aircraft are very, very limited. So this is why JetZero could be onto something huge. The thing is, the company is starting to look less like an early stage concept and potentially more like a credible threat. The CTO is Mark Page, who as a McDonnell Douglas program manager in the 1990s led a 3-year NASA initiative to investigate and design future blended wing body properties. This isn't some guy with like a Kickstarter and a dream. And the advisor team includes Bob Liebeck and Blaine Rowden, who are credited with co-inventing the modern blended wing body concept at NASA. These are the people who contributed to Boeing, NASA, and the US Air Force's X-48 BWB demonstrator to study the structural, aerodynamic, and operational advantages of a BWB concept. They know exactly what works and exactly what doesn't. The extended leadership roster reads like who's who's of aerospace. Veterans from Boeing, Airbus, Embraer, Bombardier, Pratt & Whitney, Rolls-Royce, GE, Gulfstream, Northrop, and SpaceX. These people know certification, they know production, and they know what airlines actually need. But, Credentials don't really pay the bills. JetZero needed something to de-risk the program for a brand new plane. And it needed the military. And it got them. But the Air Force didn't write a $235 million check because it likes interesting concepts. It has a genuine problem right now. You see, the KC-135 tanker makes up the bulk of their fleet, but the aircraft will soon be too difficult to keep flying, and the KC-46 replacement has been troubled. The Pacific Theater, for example, demands range. Chinese anti-access strategies push tankers further back. The blended wing body's smaller footprint increases asset availability and storage, enhancing agility and responsiveness. Higher lift also means the Z4 can use shorter runways, while its unusual cabin allows for taller pallets of cargo. And there's historical precedent here that should worry Boeing. It built the 367-80 as a commercial prototype. The Air Force bought it as the KC-135 tanker, and that tanker contract funded the development of the 707, which dominated commercial aviation for 2 decades. JetZero is literally following this exact same playbook. The military will help de-risk the entire commercial program. But that only works if the technology actually delivers, and there are 3 major technical hurdles that could stop this entire program. So, I just wanted to be really clear about something. This is really hard. There are reasons nobody has built a commercial blended wing body before. Challenge 1 is pressurization. A tube-shaped plane handles the constant expansion and contraction cycles that come with each flight, better than non-cylindrical shapes. Cylinders are structurally efficient under internal pressure. It's basic physics. A blended wing body has to pressurize a non-cylindrical shape thousands of times over the decades of service. That requires advanced composite structures tailored to load paths across the entire platform. JetZero's answer is heavy use of carbon fiber composites. It explained that with the tube and wing design, the pressurization load is on the tube, and the bending loads are on the wings. A blended wing blends those together, which can only be done now with composite materials that are both light and strong. The technology that exists today didn't exist when NASA first studied this in the 1990s. Then, challenge 2 is airport compatibility. The blended wing body is shorter, but wider than traditional aircraft. The Z4 is designed to accommodate 250 passengers with a range of 5,000 nautical miles. It's kind of putting the plane somewhere in the middle of the market category, competing with aircraft like the A330neo, the 787, and I guess to a lesser extent the Airbus A321XLR. But the thing is, this plane is going to be a lot wider at airport gates. It will create clearance issues, and it may also impact things, when the plane is on taxiways. JetZero has studied folding wingtips as a mitigation, though this is unlikely to be on the first prototype, and it's a real issue. Airlines don't love special equipment, and there could be huge costs to change gate areas at airports. Perhaps it is worth it if we're talking about 50% lower fuel burn and emissions. Then, challenge 3 is pretty obvious, but it's evacuating a blended wing aircraft. It's going to be very different to a traditional plane. You see, the FAA mandates a 90-second full evacuation with half of the exits blocked. This will drive the door count placement in ways traditional aircraft don't even have to consider. Then, cross-aisle visibility for crew during emergencies is more complicated in a 30-foot wide cabin versus a 12-foot tube. And then we also need to talk about passenger experience. Only a small percentage of Z4 passengers will get a window seat. You need to think we're talking a giant flying triangle, and the windows are going to be on the outside edge. So people at the back, you could be looking to your side and you could see a row of 20, 30 seats. So out of those 20 or 30 people, only 2 of these people are going to get a window. And that's a hard sell for many who already feel claustrophobic in a normal aircraft. The wider cabin will completely change aisle layouts, galley placement, and service flow. Design teams have investigated in the form of high-definition displays to form kind of cabin sidewall panels, projecting images such as window frames of a view, or full-length animated panoramic views of the passing sky. This has already been done in commercial aviation, kind of. I'm looking at you, Emirates. So JetZero has to solve pressurization, airport compatibility, and passenger acceptance, all while certifying a completely new category of aircraft with the FAA. But if they can pull it off, they've already got customers lined up. This is where I wanted to mention United again. They have secured a pathway for orders up to 200 Z4 aircraft. I guess this is kind of marketing talk somewhat, but I imagine the idea is they have not had to put down much money at all for these planes, but by United throwing their force behind JetZero, it gives them credibility to gain, I guess, more investment. The company has also secured investments and conditional purchase agreements from Alaska Airlines, and in March 2025, Delta also announced a partnership, donating equipment for the full-scale demonstrator and investing in cabin development. These aren't letters of intent from obscure startups desperate for publicity. United, Delta, and Alaska represent major US airlines. The trio is in the top 5 of the largest airlines in the country. They're not betting on fantasy, they're hedging against a future where Boeing and Airbus really can't deliver the efficiency gains that sustainability mandates will or may require. United's Andrew Chang, head of United Airlines Ventures, stated that if successful, JetZero has the potential to evolve their core mainline business by developing aircraft with a bigger, more comfortable cabin experience while increasing the fuel efficiency. That's airline speak for we're tired of waiting for Airbus and Boeing to innovate. And that really brings us to the real question, why on earth are Boeing and Airbus letting this happen? Well, the thing is, they're not. Airbus has studied subscale BWB concepts under the Maverick program, and Boeing has had very similar programs. Neither has committed to a full BWB airliner. Why? Airbus and Boeing have backlogs for the next 10 to 15 years. Boeing is facing its own set of issues, including current certification challenges, and really, these are priorities. When you're generating steady revenue with existing designs, revolution is a risk. Incumbents optimize what works, they defend turf, they don't cannibalize profitable product lines. It's a rational business strategy, but it creates an opening for disruption. If JetZero proves even 30% efficiency gains in a certified, I repeat certified, commercial platform, that changes the calculation instantly. And 50% would really be like a revolution like no other. Airlines are facing higher fuel costs and strict decarbonization mandates around the world, and they're going to demand major improvements. And this is where the BWB could deliver this. Even limited success gives airlines a negotiating leverage. A credible third competitor compresses margins for the duopoly, which is Airbus and Boeing. Then whilst talking about competition, I should also mention China's COMAC too. They're building a whole suite of new commercial aircraft to compete head-on with Boeing and Airbus. The C919, which is a narrow body of a similar size to the A320 or 737. Then we have the C929, which is a small wide body similar to the 787. Then they're also designing the C939, which will compete head-on with the Boeing 77X and maybe A350-1000. COMAC, however, is taking a really conservative approach to design, and I guess their goal and priority is to make a cheaper plane than both Airbus and Boeing could. Not even necessarily more fuel efficient, but this could change, especially if they delve into a blended wing aircraft. I mean, who knows? Now, back to JetZero. If they secure both the US Air Force tanker program and launch with commercial customers, their business case solidifies before Airbus and Boeing can really react. But there is something almost nobody talks about. There is a really high possibility that exists where Airbus or Boeing might eventually acquire JetZero rather than let it grow into a third OEM competitor. That would be an admission that internal innovation has failed, or a fast-track ticket to dominate the commercial aviation industry. And I guess the optics would be challenging, but the logic might be unavoidable. But acquisition only matters if JetZero can build these things at scale. And this brings me on to production. As mentioned, I think at the very start of the video, JetZero is going to be investing a whopping $4.7 billion in a factory in North Carolina to build its Z4 aircraft. They aim to create 14,500 jobs in the next 30 years or so. To enhance its hiring pool, JetZero will invest in the North Carolina Community College system to develop a customized workforce pipeline. North Carolina Governor Josh Sheen's office noted that the state's corporate tax rate and low cost of living has helped attract JetZero. The company will partner with Siemens Smart Infrastructure, electrification and automation divisions to design its factory with the most efficient technologies possible. The factory is planned to be fully digital and AI driven to outpace legacy original equipment manufacturers by ramping up faster, cutting unit costs, boosting quality and hardening the supply chain. Government loans and industry financing will be critical. But the demonstrator flight in 2027 becomes the inflection point. Prove the concept works and capital will flow. Fail, and it's basically another aerospace company that didn't make it. So, what has to go right? First, the full-scale demonstrator has to prove the aerodynamic claims. The lift-to-drag ratio, the handling qualities, noise contours during takeoff and landing, flight control laws in a non-traditional platform. If the demonstrator doesn't fly as promised, or if the efficiency gains are overstated, then the entire program will likely collapse. Second, we've got the certification pathway. The BWB requires special conditions and fresh compliance methods for crashworthiness, evacuation, loads, aeroelasticity, flutter, ditching, fire containment, and structural repair for a large composite primary structure. The 90-second evacuation rule with half the exits blocks drives door count and the placement strategy of these doors. Systems redundancy and upset recovery in a new platform need validation. The FAA will scrutinize everything because they have no precedent to fall back on. One major safety issue during certification and the program timeline will likely explode. And then third, airline and lessor acceptance. Residual values depend on fleet commonality, crew training pipelines, MRO ecosystems for composites and non-standard structures, and spares pooling as well. Seat mile, cost sensitivity to stage length and payload also matters. Passenger experience, service flow, and brand acceptance has to work. Lessors will not finance an aircraft with uncertain performance and residuals. Airlines won't order aircraft that passengers hate flying in. It's as simple as that. If any of these three things fail, this stays as a fascinating engineering exercise. I think the real problem here is that aviation is facing a major sustainability challenge that incremental engine improvements are not going to solve alone. Net zero commitments demand solutions beyond sustainable aviation fuel blending. Airports are facing higher and higher noise pressures, and airlines are also facing volatile fuel costs. The tube and wing design has been refined to its practical limits. Composite materials, geared turbofans, ultra-high bypass ratios, and advanced winglets are all excellent, but insufficient for the next step that aviation really needs. JetZero is betting that physics has been waiting for manufacturing, technology, and materials science to catch up. And it's a bold bet, but if the math checks out and the team does have the credibility to pull it off, it's going to be crazy. Remember, this design has already been proven in wind tunnels. It's flown as demonstrators, studied by every manufacturer. The technology works. The question was never, can it be built? The question was, who's willing to take the risk?